I'm going to start webinar, which will allow people to enter. So we'll just give it a little bit of time here and talk. And so go ahead, Dustin, you can go ahead and welcome to the National Biodiversity Teach-In, and thanks for doing this, both Dustin and Grant.
Yeah, welcome everybody. This presentation is sponsored by the Community-Led Environmental Action Network in the Elgin area, or known as Clean Elgin. Clean is focused on advocating for policies that implement sustainability practices in School District U46. This includes fostering a community that understands the importance of sustainability and actively works to improve our shared quality of life. This growing organization is excited to provide opportunities for residents and students to get engaged in environmental initiatives throughout the Fox Valley and beyond. If you want to get involved or if you have any questions, please reach out to us at elginclean@gmail.com. With us today is Grant Shadden. He's located in Tama, Iowa right now, within Meskwaki Nation, and is going to tell us a little bit about partnering with nature. So if you don't mind, you can take it away, Grant.
All right, thank you, Dustin, and thank you everyone for being here. I'm excited and honored to be rounding out this National Biodiversity Teach-In with this presentation on partnering with nature, regenerative agriculture practices for increasing biodiversity. A lot of times people think that promoting biodiversity is about conservation, which it certainly is. But today what I want to share is the possibility of being able to use agriculture and what we call agroecological systems that mimic nature in its patterns, energy flows, interactions with different living creatures to have a mutually beneficial partnership with humans in the built environment, in our agricultural systems, and all other life forms. So brief introduction about Red Earth Gardens. Our motto is growing food, farmers, and community. And Red Earth Gardens is part of the Meskwaki Nation Workforce Development Department. And it is the only tribe in Iowa. And this farm was really born from the desire to regain food sovereignty. And the farm is growing healthy beyond organic produce, developing the next generation of the Meskwaki workforce and demonstrating regenerative agriculture practices. We go beyond organic with our produce, believing in healthy land and healthy people. And so before there was even the concept of organic, the Meskwaki stewarded the land and partnered with nature in meaningful and highly functional ways. We continue the tradition by moving beyond the minimum organic standards to maximize both ecological benefits and quality of produce. And then the last part, growing community. We gather together and it reminds us who we are. The Meskwaki are the people of the Red Earth. Gathering around food reminds us who we are and where we come from, as we remember and celebrate our deep connection to the land and each other. Here's a few photos from the farm. Like I said, and as Dustin introduced me, my name is Grant Shadden. I'm the farm production manager at Red Earth Gardens, the Meskwaki Nation in Tama, Iowa. I was a 2005 graduate of Iowa State University. And when people hear that, they say, oh yeah, it makes sense. That's a good agriculture school, which it is. But I graduated with a degree in psychology. So I took the long way around on my career path. And that was partially through volunteer work in Sierra Leone, West Africa, as a house parent at an orphanage after their civil war. And it was a really eye-opening experience, seeing poverty, seeing the fragility of ecosystems and how that affected quality of life for people. And so I'm not going to go through my list of certifications and things. They're there for viewing, but it really set me on this course of learning deeply of how to connect with nature, how to restore and regenerate the land, and people as a result. So quickly, what is biodiversity? And I took this right from the National Biodiversity Teaching website. So biological diversity or biodiversity means the variety of plants, animals, and other living things in a particular area or region. Biodiversity also means the number or abundance of different species living within a particular region. These regions are called ecosystems, natural areas made up of a community of plants, animals, and other living things in a particular physical and chemical environment. Biodiversity suggests sustaining the diversity of species in each ecosystem to coexist with human life. And I made it bold there, sustaining, and we'll talk about that. If sustaining is really enough in this current situation we find ourselves in on this planet. So ecosystem diversity and diversity of species. We see all different types of ecosystems across the planet, and they're all there for a specific reason and have developed out of their own unique conditions with where they are on the planet, climate, soil type. And there's so many fascinating and complex relationships between what lives in the ecosystem and how the local ecosystem shapes those living things, but then also how the living things shape the ecosystem. It's fascinating. Healthy ecosystems will support species diversity that maintain balance in the ecosystem, as long as we do not do too much damage. Biodiversity is beautiful and functional. When you see all these different shapes, colors, forms, patterns, they all are performing a function, whether it's the shape of an insect, its color, its size, the same thing with the flowers, the plants that you see, and they all interact and relate with one another in meaningful ways. On the left, you have a diverse array of members of the fungal kingdom, and that is just a sampling of what was found in a forest walk. And so this was in one specific moment in time in a season. Throughout the course of seasons, depending on temperature, day length, things like that, you'll get even different species of fungi coming out of the same forest environment. And then, of course, we see some different plant species as well. And then here we get to different types of trees, some climbing vines there. This was actually at the Entebbe Botanical Gardens in Uganda when I was there teaching what's called a Permaculture Design certification course through some partners at Reconnect Africa. And there was over 450 documented species of trees on this 45-acre site. And they're all there for a reason, supporting different life forms. And then again, just the beauty in the array, the variety of biodiversity in these animals. Yeah, any other examples of biodiversity? So healthy soil is full of diverse microscopic life that are the essential building blocks to support a biodiverse, healthy ecosystem. The more life there is below the ground, the more life that can be supported above ground. It all starts with healthy soil, so it is important we take care of it well. You can see bacteria, fungi, protozoa, nematodes. These are all microscopic, too small for the human eye. We have to use high-powered microscopes to see them, but they have a massive impact on what is happening and what we see and experience above ground. And then on the right, above there is microarthropods, which those are microscopic, tiny insects that live in the soil and can come up on the plants. And the bacteria, fungi, and they can come up on the surface of plants. We just can't see them as well. And in the bottom right, you see those are called fungal hyphae, or they're just these threads of underground fungal species that play a very key role in soil and plant health. And we'll talk about that a little later.
We had a question come in from Facebook Messenger.
Yeah.
Julia would like to know if you have a favorite plant or favorite interaction relationship between two organisms.
Oh man,
It's a tough one.
that is a tough one. Favorites. My wife always gives me a hard time because she'll ask me, you know, people ask favorite movies, things, and it's hard for me to choose favorites, especially with plants. It was Julia.
Yeah.
Julia, we'll probably get to that a little bit later, a specific relationship. Actually, since it's on the screen here, that thread you see, those white strands, you can't see a plant root there. But I would say this is probably my favorite right now because I'm really studying soil microbiology. So those white threads, they live below ground and they connect to the roots of plants, trees, grasses, vegetables in our gardens. And they will attach to the root of the plant. And since they can't photosynthesize, take energy from the sun and convert that into sugars and things, they connect to the root of the plant, and the plant gives and shares those extra sugars, proteins, different compounds to that fungal thread. And in return, that fungal hyphae, which the specific variety, they're called mycorrhizal fungi. But that fungal thread will then go and communicate with the root of the plant, and the plant will say, I need a calcium molecule or nitrogen, or I need some water, and it will go and get it from the soil and bring it to the plant. Amazing partnership and relationship. So they are helping one another live and thrive and coexist. And that's the beauty of partnering with nature, when we can develop some of these agricultural systems that mimic what happens, like say in an undisturbed, healthy forest soil environment, which is where it's the easiest to find mycorrhizal fungi. When we start to take those lessons from nature and apply them to our agricultural systems, we can have incredibly healthy food while we're also actually helping to clean the water instead of pollute it, clean the air instead of pollute it. There's amazing things that can happen. So very good question. I could talk about soil science stuff for hours and hours, but we don't have that time. So we'll continue on. So of course we have so much diversity in humans and different ethnicities, and where we're from, the region, the climate shapes our culture, the foods we eat, how we live life on this planet. And there's lessons to be learned from one another, because there can be unique challenges in each area. And if we'll communicate with one another and understand that everyone has something to teach and everyone has something to learn, we'll all be a lot better off, I think. So humans have not done so well stewarding biodiversity as we have developed modern societies. And sustainability has been a really big talking point and a buzzword. And is that the answer? I would say sustaining our current conditions will not be enough. We're really in a critical period of time with habitat loss for biodiversity and just overall planet health. But we need to partner with nature and use regenerative practices. So regenerative means able to or tending to regenerate, which means to regrow or be renewed or restored, especially after being damaged or lost. The act or process of regenerating is regeneration. So anything that's regenerative is working to actually recreate, rebuild. So we've lost so much of our topsoil especially in Midwest farmland in the United States. Actually, by tonnage, just by sheer weight, the United States' largest export of what's leaving our country is our topsoil out of the Mississippi River, and creating that large dead zone in the Gulf of Mexico because of all the ag chemicals that are going in there. And we can start to partner with nature to not continue to do that level of damage and to clean those rivers of the soil and all those chemicals. So you can see on that graph, if we just go with sustainability, that's just sustaining means to maintain the current condition. So if we sustain where we're at, we're in a fragile place right now. So we really need to look ahead to begin to rebuild and regenerate our resources, our land base, habitat for native wildlife, to build that new balance and resilience in our system. And so this will provide for our needs while also creating and managing the conditions for life to thrive for all other life forms on Earth. And it can be done. There's working examples of it. So we'll kind of skip this because I'll speak about it here. So I would call most agricultural models that are being practiced on the most acres across the US certainly, and most of the world, degenerative, which means there's an exchange for the product, the crop that's coming off the land. And it's usually loss of topsoil, loss of wildlife habitat, loss in health and condition of our water. And so regenerative, as we talked about, is rebuilding and recreating that. And if we create the conditions for life to happen, it will. Nature is incredibly resilient and forgiving. And I've seen this in my my regenerative design work and installation work that I've done in the past, both in Africa, here in Iowa, and when I was working out in Montana, that if we take one step towards nature, it takes 10 steps towards us. But we've also seen a lot with climate change and natural disasters and things like that. There was a Japanese natural farmer, permaculturalist. His name was Masanobu Fukuoka. And he had a quote that translated in English to, "If we throw Mother Nature out the window, she will come in through the front door with a pitchfork." And I think we've seen that. And we need to really pause and consider where we're at and start taking those steps towards Mother Nature to partner with nature in meaningful ways. And when we do that, we can create agricultural systems that support ecology and economy at the same time. So how do we effectively partner with nature to move from degenerative to regenerative systems? We can understand we are a part of the problem, and we can slow down and begin to observe and interact with nature. And then we can begin to learn and experiment and have that natural curiosity take us to really interesting, exciting, promising places. And then begin making choices that support nature and regenerative systems. And we can volunteer and work to create habitat and living systems. So regenerative agriculture is a conservation and rehabilitation approach to food and farming systems. It focuses on topsoil regeneration, increasing biodiversity, improving the water cycle, enhancing ecosystem services, increasing resilience to climate change, and strengthening the health and vitality of farm soil, which healthy soils create healthy plants, and that creates healthy humans. It's in our best interest. So with regenerative agriculture systems, we look to nature for our example, and we work to design, develop, and manage systems that closely resemble local ecosystems to create biodiverse, lively agroecological farms. And when I say agroecological, it's really that combination of an agricultural system that honors and really mimics what we see in local ecology ecosystems, how plants, animals, the wind, the sun, the rain, all those things interact with one another to keep maintaining and building systems that create more and more life. So we can learn from the past. Sorry, I lost something here. Give me a moment. So we can look at our local area. What was the natural climax ecosystem like before we intervened heavily? And how do we design and develop systems that resemble these natural patterns and flows of life and energy? An example from where I'm living, and Elgin, Illinois would be included. I know there's people from all over, but it's relevant to this local area, is the Midwest oak savanna ecosystem before European settlers moved in and began changing it significantly. So even before the dinosaurs were extinct, you have the American mastodon in an oak savanna habitat. And then you see at the right, the elephants in an African savanna. There's potential threat of extinction due to climate change, habitat loss, and poaching, unfortunately. Now, you can see how similar the mastodon and the elephant look, right? Their size, their body structure, and their diets would have been similar. What they would go after, grazing and browsing. Browsing is woody perennials, eating the leaves and the tender growth tips from trees and shrubs. Grazing is any kind of the softer herbaceous plants in the grasslands. So that's a very interesting comparison there. And when you look at the left, now this is Africa and the savanna during their migratory season. But on the right, you see the American oak savanna. And where are all the animals? We'll get to that in a second. And savannas are the land-based ecosystems that are the most productive in terms of pounds of animals supported per acre. African savannas still display the interaction of what we call megaherds of grazing herbivores in near continuous movement for available food and predator avoidance. If you've ever seen, the nature documentaries, which if you haven't, Planet Earth, things like that, anything National Geographic, to watch the hunting predators pursuing these large herds, you can begin to understand how these large herds of animals are always on the move. And so there will be these short periods of what we would call high animal impact, a lot of grazing and browsing, a lot of deposit of their manure and urine, which puts nutrients back in the soil and stimulates soil biology. But then they move on, and there's a long recovery period for that area to regenerate and continue to build resources for the next time they come through. So if these are the most productive natural land systems, can we look to nature's model to be informed and inspired to develop systems managed by humans that are as productive and ecologically responsible? So this kind of answers where the animals and where the oak savannas are in the United States. The indigenous people of America sustainably hunted the buffalo herds, maintaining healthy large herd numbers and applying predator pressure along with wolves and other predators to keep the herds moving. allowing the grasslands and oak savannas periods of regrowth and recovery, which maintained healthy grasslands and soils. Unfortunately, the US government had 1.5 million buffalo killed in 1873 alone to make tribes dependent on the government for help, so they could displace them from their land. And this was throwing the ecosystem off balance as well. And it's a sad picture in that bottom left, but that is actually a pile of buffalo skulls from that agenda of killing those buffalo. And this really was to make way for settlers to begin plowing and doing agriculture. So at first, the fields were incredibly productive. They were planting the rich, fertile soils of the oak savannas and grasslands of the plains, which had been made that way through the biodiversity and functions of the ecosystem. But immediately, this began degrading the condition of the soil. And as equipment developed and modern agriculture developed, we could till harder, deeper, but with heavier things. This led to soil erosion, the need for more and more chemical inputs. And you can see the bottom right, those are different layers of compaction. And once the soil becomes so compacted and anaerobic, all the air spaces are pushed out. So the soil, it's a living thing. So now it can't breathe very well. And when living things can't breathe very well, they begin to die. And so a lot of the soil is really, for the most part, dead. There's not all those soil microorganisms in them. When you till the soil, you kill the soil. You're cutting up, crushing, but also creating these conditions we don't have time to get into today, but that really cause a severe drop in not just the diversity, but the amount of soil microorganisms. And this leads to dependency on those chemicals. So we kind of took that model of the buffalo on the grasslands, and we plant corn, soy, we plant other crops for conventional beef production models that are disconnected. So a food source is grown far from cattle, trucked in, fed in confined areas, which have too much manure and urine runoff when it rains, causing pollution downstream. Corn is also not what cattle are naturally adapted to eat, although they can eat and healthily digest thousands of types of plants, including the leaves and tender shoots of many trees and shrub species. And they can eat a lot of plants that we cannot digest. So they're woodland or grassland, or another way of putting it is savanna edge species. They like to live in those places where there's trees and grasses together, just like the buffalo, just like the mastodon, these large herbivores. So we can reconnect cattle and other livestock directly to the land through planned rotational grazing. With planned intensive rotational grazing, we can reconnect the land with large herbivores, increasing the health of the animal, soil, ecosystem, and people. So you can see the diversity in the bottom right of the plants as you continue to rotationally graze, mimicking those short periods of high animal activity with long periods of recovery. The plant diversity comes back up, soil microorganisms improve, we sequester carbon in the soil, and instead of using predator pressure, we use timing with electric fences to move them. So we can add biodiversity to our grazing plans, like leader, follower, multi-species grazing. So in this case, at ABC Acres in Montana, where I worked to design and develop this farm and get it going, we used chickens behind the cattle to reduce hornfly populations. So these are pests to the cattle, causing them stress. They worked in partnership as the cattle grazed the grass lower, clearing the way for the chickens. And the chickens eat many different things, including scratching through the manure to eat the larvae of the hornfly. And that greatly reduced the fly populations. So this leads to calmer, less stressed cattle, which gain weight more effectively. You'll also note some trees behind those fences, and there's even some bird houses on those fence posts because we were encouraging more layers of diversity. So here you can see on the right, planned rotational grazing being used, leading to healthier pastures and soils. On the left, that's called set stock grazing, and oftentimes it's overgrazed, and it begins to degrade the pasture and the soil. And this is more and more important to use rotational grazing in more fragile environments and ecosystems that maybe don't get as much rainfall or don't have as resilient of soils to begin with. So now we're going to talk a bit about silvopasture, which is the combination of trees and pastures together, most often with grazing livestock integrated into the system. So this is beginning to get very close to oak savanna ecosystems. There's many different possibilities and layouts that exist, depending on the unique context of the land, which just means the unique situation of the land and the desired farming operation and the existing or emerging markets for products, whether it's using nut trees, fruit trees, timber trees, anything, berry bushes. There's all sorts of different tree and woody shrub crops that could be integrated into these systems. And they also provide habitat for native wildlife of all sizes and varieties at the same time. There is a farm called New Forest Farm in southwest Wisconsin that uses a lot of these techniques, and they've actually had researchers from universities come out because they will have actually a higher diversity of migratory songbirds at this farm than in even conservation reserve program areas or in state parks, because of the just the high amount of biological activity occurring and energy happening with all these animals and plants interacting together on the farm. So another way to do it that might work more with tractors and things is alley cropping, which is growing strips of row crops or pasture in between rows of woody perennial plants like trees and shrubs. And this can be transitioned to a savanna system. And this mimics the large amount of edge between the forest and grasslands, which tend to be the richest areas of biodiversity. So you always can see squirrels, rabbits, and things running into hedgerows underneath bushes and trees, birds that will nest in there, fly around. They're very active areas. And so if you just have this repeating pattern of open grasslands, or you could be growing row crops in between, and these tree lines, you have so many opportunities for rich, biodiverse agroecological systems. So we can also have beneficial insect habitat plantings that attract insects that will compete with and prey upon pest insects that damage crops. So this leads to increased biodiversity, as well as reducing or eliminating the need to spray chemical pesticides, which will kill more life than just the pest, including soil microbiology. So on the bottom left there, you can see those grasses. Those are native grasses planted in something called a beetle bank. And it's habitat for native beetles that prey upon many soft-bodied pests to vegetable crops. So you can see it doesn't take a lot of field space to put these in every once in a while. And they're more than happy to do the work of pest control for you. And then on the bottom in the middle, this is from Red Earth Gardens here, a shot. You can see these different flowers. We've got marigolds interplanted with our summer squash. We have calendula flowers that repel pests. And then there's the frilly umbrella-shaped dill flowers that provide habitat for parasitic wasps. They're very small members of the wasp family, but they do a good job in controlling insect pests as well. So that's something that we do at Red Earth Gardens is we always try to interplant, ideally, something that could either be a cut flower or a medicinal or cooking herb, uh, or sometimes they're just providing an ecological service and habitat for insects, for invertebrates um, that will benefit us, but are also giving back to the natural ecosystem. Hedgerows, so just lines of shrubby plants or large herbaceous plants, most of the time perennial, are a good way to have habitat. And a lot of times they could be something that could be an additional crop like elderberries. And then also these unique structures called insect hotels. They're a good way to provide habitat for a diverse variety of beneficial insects. And this one in particular, this is just pallets stacked on top of each other with different both natural and man-made materials to provide all these different unique spaces for beneficial insects to live in. So a couple of good resource books for further study into partnering with and creating habitat for native pollinators and other beneficial insects come from the Xerxes Society. They've got some really good information, even at least as far as the United States is concerned, by region of what common pests are, what the beneficial insects that control pests are in your region, and then the plants that you can put into your systems to attract those beneficial insects. So those are some good resources for further study if anyone's interested. So we can also bring in some other flying helpers, bird houses. Here on the right, those are kestrels, and out in Montana at ABC Acres, we put kestrel boxes up, and within a couple months had kestrels in them, and they're small predatory raptor birds that can just hover. If you've ever been driving along in the Midwest and seen them along fence lines, they kind of hover above the ground and then all of a sudden they'll drop, and they're usually going after small rodents. So they help minimize crop damage in that regard. Bat houses on barns and barn owl boxes all can, even at night, you could have flying insect and rodent control happening around the clock. Who wants to be out with a flashlight trying to stop rodents or monitor for bugs? We can partner with nature and give them a space to live and thrive, and then in return, we don't have to use as many chemicals, or if any, to have these productive, healthy systems. So I'm really studying soil microbiology right now with the Soil Food Web Academy. And it is really the starting point of a healthy, biodiverse ecosystem and planet. So like I said before, the more variety and amount of life below ground will support higher variety and more life above ground. So we really need to look at that in our food production and resource production practices. So you can see, these different relationships happening. The bacteria are the smallest, and they're living around in the soil. The fungi, nematodes, which are like basically microscopic worms, and the arthropods, those microarthropods are microscopic insects. And then you get into larger insects. We have the protozoa as well. And then obviously birds that are poking around, scratching around at the surface, burrowing animals, all creating this system where when it's in balance and there's the right amounts, they keep the soil aerobic, loose, and aerated. They let the rain in easily, but they also retain moisture. They help nutrient cycle and make those nutrients available to the plant. We talked a little bit about that with mycorrhizal fungi, how they relate to the plant roots. And there's so many amazing things happening that really, with conventional agriculture, gets taken away when we till the soil. And when we till the soil, we kill the soil. And then there's this need for more and more synthetic chemical fertilizers, pesticides, herbicides, fungicides to try and artificially reproduce what can happen in natural ecosystems. And then that pollutes the surrounding waterways and soils. And then this causes health issues in people as well. So with row crop production, I don't want to be judgmental about it. It's the system we have, and there's ways to still grow corn and soy in the Midwest in the United States by being more soil conscious. And so we can use things like cover crops. And here you see a tractor that has something called a roller crimper on the front, and it's rolling down a crop of what's called winter rye or cereal rye. And then behind it is a no-till seed drill planting soybeans. And so you have this living mulch that then once it gets rolled down, so all that time it was growing, it was putting those sugars, feeding soil life. Those roots are structuring the soil, doing all these great things, providing habitat for insects, for small mammals, for birds. And it gets rolled down and planted into soybeans. And now you've got mulch covering the soil so it's not bare, not getting eroded. It's feeding soil life still. It's holding moisture in the soil while you have a cash crop growing. So the good news is, while we've got a lot of damage to our agricultural soils and then pollution in the surrounding ecosystem as a result, we can quickly take degraded, mostly lifeless soils and regenerate them with the addition of biology from well-made compost, which is decomposed mix of organic matter. It goes through a process involving time, temperature, moisture, and soil microbiology. It yields a fertile but mostly microbially diverse and dense end product when it's done properly. And liquid extracts from highly active biological compost material can be used. And it's important to get the process right so that the end product is helpful. That's why we monitor and test using microscopes and best production practices. So composting can be done on any scale, from a small pile in your backyard with worms in a worm farm, which happens to be one of my personal favorites because they're just fun and they make a fantastic end product. Or large machines with these tractor-powered compost turners. You can do tons and tons of compost turning in an hour with one of these. So I'm taking courses from Dr. Elaine Ingham. She's one of the world's foremost soil microbiology experts. She has a school where people can be trained in the 3-step approach to restoring and maintaining the soil food web for greater yields with less or no inputs of fertilizers or pesticides or herbicides. So this reduces the cost and it creates higher quality food while also supporting a healthier environment and planet. So instead of chemistry, we can use biology and actually increase profitability for the farmer while also creating a healthier environment at the same time. So you can see the 3-step approach here. Identify which groups of microorganisms are lacking in the soil. You boost their numbers using biocomplete compost and liquids, and then adopt natural farming techniques or regenerative farming techniques to ensure that the biology survives and thrives. So this goes back to Julia's question. Here's a picture of mycorrhizal fungi. So you can see the kind of tan, brown, yellowish colored, those are the roots of that young tree. But all those white threads are mycorrhizal fungi. And so you can see how much more surface area of the soil is being interacted with that mycorrhizal fungi connected to those plants, how much more available, is the resources of water, of nutrients, and it's structuring the soil, opening it up, allowing it to breathe. These are really meaningful connections. And so when we till, that cuts up and kills fungi and the other soil microorganisms as well. It breaks this relationship up. And now you get on that kind of hamster wheel of needing those external synthetic chemical inputs to try and recreate what nature can do on its own if we'll just partner with it. So at Red Earth Gardens, we've built a couple of these Johnson Sioux compost bioreactors. So they produce a fungal dominant, biologically diverse compost that can be used to restart the soil food web's functions, and benefits can be seen in the first season. And so there isn't, you fill this up and you let it set and you pull those plastic pipes out, and then it's just actively aerated without having to turn it. You keep it moist, it takes over a year. But at the end, a good batch will have over 4,000 species of bacteria and over 400 species of fungi. And then there's also many different varieties of nematodes, protozoa, microarthropods in there as well. So talk about biodiversity. And you can have in a palmful of this stuff, billions of microorganisms. And then you can add only 2 to 4 pounds of that in 20 gallons of water in a mixture, and you'll have a liquid spray that will treat 1 whole acre. At the cost of, if a farmer was making this themselves, it would be at the cost of about 50 cents to $1 an acre to restart that soil food web. And farmers that have started doing this are getting about the same amount of yields in production. I've seen case studies with corn as if they were applying over 150 pounds of nitrogen fertilizer per acre. So if we can get this adopted on large scale, the impacts will be huge. And the farmers make more profit per acre. And that's the way it should be. They're taking care of nature, and in turn, nature takes care of us. So we're kind of rounding it out here. On the left, you can see this says soil biological succession causes plant succession. So if you see on the left, it's bare dirt. So that's any kind of mass disturbance event, So for example, cutting down trees and tilling to prepare a field for crops. Well, now you have just bacteria. They're so small they can survive, but there's not as many of them. And there's very, very little fungal. And so then you also see on the bottom, it says more nitrate, the type of nitrogen needed. So bacteria like nitrate more than ammonium. But weeds, what we call weeds, also like nitrate. It's what they feed on. So we've now created the conditions where we don't have the full soil food web working, and we've just tipped the scales to the advantage of what we call weeds, which I would say a weed is nothing more than a plant that is growing where we don't want it to. What a weed really is it's nature's soil repair mechanism. If they're working to try and rebuild the soil because it's been severely damaged. And so they're trying to help in this natural succession. They're trying to bring nutrients back, those long tap roots of some weeds like dandelions, different things. They're trying to restructure the soil, hold it together, keep it from being compacted. And then a lot of people spray chemicals on them to get rid of them, but they're really nature's messenger that there's something out of balance. So if we can reapply the biology, we can quickly start to get to where we're more at that 1-to-1 ratio, which is right where you see balanced in the middle, where it looks like there's more advanced grasses and other herbaceous plants, and right on the edge of where trees are. Remember that oak savanna system, that edge between trees and grassland and things? and those silvopasture systems. So we can convert farms into these agroecological systems that partner with nature while regenerating resources and balancing the planet's water and climate cycles. And on the right, this is from the Savannah Institute. This is kind of, you see it mirrors in a lot of ways the natural succession of an ecosystem that, this would take on the left, if someone just came with a bulldozer and leveled a forest, cleared it for maybe a housing development, then they ran out of money and they left it, you would see weeds, and then you would see some little shrubs and things, and then trees. But this is going to take decades to ever turn into a forest again. Many, many decades. But if we partner with nature and we design these systems, like on the right, we can be growing crops all the while and building up those soil microorganisms until we get to that point where, like on the right there, you see silvopasture systems, but you could be growing annual row crops. In the meantime, the farmer still has income coming in. So these are things that, especially in this United States Midwestern context, that really need to be explored and developed more for the world we find ourselves living in, and the climate conditions and the depleting natural resources. And when you look at that illustration there on the right, there's so many opportunities for life to happen, for biodiversity, for the continuous photosynthesizing of plants throughout the year to feed soil life that then in turn supports more life above ground. So when we create the conditions for life to happen, it will. We can partner with nature for the benefit of all life on this beautiful planet. We can work together by making choices to live in and leave a world for future generations that is fruitful and abundant. That's a picture of me when I was living out in Montana, and my son. It's handing him an apple, but I think it's very symbolic of the work that needs to be done to leave future generations a world in better condition than the way we found it. And that's really the native land ethic, like how we treat the land. And I'm not a Native American. I am just someone who has the opportunity to work for the Meskwaki tribe. But I've already been on this journey, and then I've had the opportunity to learn even more from them, which I've been thankful for. So Ketebe, which means thank you in Meskwaki. I have my contact info here, my email, and then some other links and things from things I spoke on during the presentation. And if anyone has any questions, let me try and get to the chat here. We can look.
Thank you, Grant. I know one that came in a little bit earlier. I think people were kind of blown away with all the knowledge that you have. So they're wondering, where does somebody start? Where would you point somebody? What direction would you point them in to start learning about, I guess?
Yeah, that's
holistic
a great question, and it can be so I'll share my personal journey. So I was a psychology major. We had a garden when I was growing up, but then we moved to a bigger town, and there wasn't room for a garden anymore. So I wasn't a farm kid, and we camped and things. But I always appreciated nature, but I really didn't have a lot of knowledge around it. But when I saw the conditions of a post-war Sierra Leone, and these kids that were not only orphaned from their parents, but also orphaned from the land, that shook me in a deep way, and led me to ask a lot of questions. And so I kind of went on this journey of learning about resource exploitation, geopolitical things, and quite frankly, I got angry. But then through my own personal spiritual journey and things, kind of came to the point where I felt like God was saying, do you want to just focus on the problems, or should we really look at the solutions? And so I started in on that, and I quickly came upon what's called permaculture design. And so I started getting trained in that. And I am a researcher. So whenever I get into something, I go deep. So I went to permaculture design certifications, and then I immediately started putting it into practice. And that permaculture is a good start. And there's if you're looking at and I'm a permaculture certified instructor. I've taught courses in Africa and done classes in the U.S. And if it's rotational grazing, holistic management is a good place to get started. You know, there's all these different niches and opportunities, just like in ecosystems. It really depends on your own area and you know what you want to do. You know, and there's so many needs in the world today. And I I've heard this quote that sticks with me. Uh, it's important to think about that, but don't ask what the world needs. Ask what makes you come alive, and go and do that, because what the world needs is people who have come alive. And when I started learning about this stuff and getting into it, it's what made me come alive. So yeah, to point to one book, you know, there's Introduction to Permaculture, the Holistic Management Handbook. If it's more school age kids, there's a guy named Matt Powers who has actually some curriculum called the Permaculture Student. I unfortunately didn't have that link, but if you Google Matt Powers, the Permaculture Student, he's got like a K through 12 curriculum based around permaculture. I would love to see that in every school across the country. Yeah.
Thank you for sharing those resources. And yeah, I think a lot of us would like to see that sooner than later in classrooms.
Yeah.
I guess one question I'm personally curious about is, do you have a favorite thing that you've learned since working with the Meskwaki tribe?
Yeah, you know, they've got a lot of really interesting and beautiful like cultural traditions that I think would be good for all of us to take pause and consider. One thing specifically with the garden, growing food is a sacred thing to them. It goes beyond just sheer production, and how you carry yourself, the energy that you're emitting is one way people would put it. But you know, the condition of your heart, what they would say, are you thinking and feeling in a good way? If you're angry or stressed, then you're not even supposed to go into the garden. And if you become that way in the garden, you're supposed to leave and get your heart right before you interact with the seeds, with the plants, the living things. And there's actually research now because of quantum physics and you know just all these incredible breakthroughs in scientific discovery showing that there is a communication that can happen between plants and people. That plants communicate with one another. They emit frequencies, and that's actually stressed plants send out stress signals, and that attracts pests. And that really strong, vital, healthy plants, even underground, they're communicating through these different root connections. Where if a pest will land on a plant, like in a row of tomatoes or something, in healthy living soil, if a pest lands and starts chewing on it, they'll send information through their roots, and it's a early warning system saying, hey, this thing is here. And so the other plants start producing these bitter compounds called alkaloids that make them less tasty to the pest. We do not even begin to understand the incredible connections there are and the things that are happening, even on like a beyond microscopic, molecular, energetic level. And you know, the Meskwaki, these other native tribes, they had it figured out just in their spirit hundreds of years ago, thousands of years ago, that how we think and how we're feeling when we're interacting with stuff directly has an impact. I can't obviously get into all of it, but that's besides soil microbiology, some of that's been what I've been, I guess, nerding out on lately.
Very interesting. Well, thank you for sharing those resources and answering some questions. We have come up on the 3 o'clock hour. So I believe that's a wrap.
Yes, and thank you so much, Grant. You were the perfect way to end the National Biodiversity Teach-In. So thank you very much. I learned so much.
Thank you so much. I really am honored and deeply appreciative that the National Biodiversity Teach-In exists. I think the work that's happening here is so vital. Thank you for the work you're doing. Thank you for everyone that tuned in and listened, and go learn, go get your hands in the soil once it warms up, if it's cold where you are, and connect with nature, learn how to create these living systems that can leave a brighter future for all of us. Yeah, thank you.
Thank you. All right. Thanks, everybody, and thanks for participating. We'll see you next year.
Bye.